Let's talk about one of my favorite algorithms. And it's one of my favorites because it's really quick and pretty cool the way that it works. I'm referring to binary search. Its main purpose is to find the position of a target value within a sorted array. And that's important to remember, the keyword sorted, because without it being sorted, we're not able to implement this. And the way it does this is by comparing the target value to the middle element of the array. If they are unequal, the half in which the target can't be in is eliminated, and the search continues on the remaining half until it finds it, or it indicates it doesn't exist. Let's take a look at this visually. Let's say I'm searching for the number 88. Our algorithm will look for the midpoint, which is 80. And then it'll compare to see if 88 is greater or less than 80. If it turns out to be false, that 88 won't be on the left-hand side because 88 is clearly greater than 80, it's eliminated. So what you see here in gray with 2 through 80 is completely eliminated and ignored. Then we repeat the process with a new starting point of 82, and knowing that the ending point is 88, we look for another midpoint, which turns out to be 91, at which point we then eliminate the right side of the array because 91 is greater than 88. And then we continue on to get the next midpoint, which is 87, and then finally we narrow it down to 88. This is how I want you to imagine the array. We have 3 key variables. P is the index of the first element, Q is the index of the midpoint, and R is the index of the last element. We're going to be using these variables in our algorithm. A couple more to remember is A, which is just going to stand for the array, and N, I'm going to reference N, and it's just going to mean it's the length of the array. In our code, we're actually going to write out A.length minus 1. It's equivalent. Just know that when I refer to N, I'm referring to the length of the array. Our algorithm can be in one function, and we could name it anything we want. I'm going to choose to name it binary search, and it's going to take 2 parameters, A for the array itself, and X is going to be the value that we're searching for. The goal of the algorithm is to find the position of X, and if we don't find it, we're going to return -1. So just keep in mind that inputs will therefore be A and X, and the output will be either the index position of the value we were searching for or -1. Now let's go over the steps that's involved in order to accomplish this goal. The first thing we're going to do is set P to equal to 0 and set R to equal to N, which N is simply the length of the array. So in our code, it's going to be A.length minus 1. The next step is going to be a while statement where we check to see if P is less than or equal to R. If so, do something. And the first bullet point here is that we are setting Q to P plus R divided by 2. And all that is finding the midpoint. And the order of operation is important. P plus R must be executed first before it's divided by 2. And after finding the midpoint, then we just need to know what side of the array to eliminate. And that's what the next 2 bullet points do. If X is less than the array with Q as the index, then we set R equal to Q minus 1. We're narrowing down to the first half of the array. Step 2 is a while loop, and we check to see if P is less than or equal to R. If so, we're going to do something. This is where we begin the process of narrowing down the range. The first thing we do is set Q to P plus R divided by 2, and the order of operations is important, so it's significant that P plus R is in parentheses. Right after that, we need to determine whether to eliminate the left side of the array or the right side. And we do this by checking to see if X is less than the array at the index of Q, and if so, then we set R to equal to Q minus 1. That is, we're setting R to the midpoint. We're narrowing down to the first half of the array. If I jump back to this slide here, just envision R, remember it being the end, moving over to the midpoint. And so therefore, we then focus on the left side of the array. On the last bullet point, we're just doing the opposite. We bring P to the right of the array. And we continue doing this until we find our value. But if it's equal, then at the very last line of the bullet point, you see that we are returning Q, and that would be our value. All right, enough of this slide. Let's go ahead and jump into some code to make some sense of this.